Okay, so let's start. Hello, everyone. At least Sun is here. So let's start with this tutorial on recent advance on automatic dialogue evaluation metrics. This tutorial is presented by Chen Chan from NUS, and by myself, Luis Fernando from Universidad Politécnica de Madrid in Spain. Okay, let's go through the content of the presentation. This is the overview. First, we will go through an introduction. What is a dialogue system? How do we measure progress on dialogue system? Especially, we will focus on human and automatic evaluation systems or models. Then we will have two main components or two different types of evaluation metrics. One is what we call reference-based metrics. We will see those metrics that require training and those metrics that do not require any training at all. We will be spending around 30 minutes for this part of the tutorial. Then we move into reference-free metrics. This is the largest part of the tutorial because it's the current trend and the most important mechanisms that we are developing right now for dialogue evaluation. Again, we have untrained metrics and trained metrics. So we will be explaining different approaches at tone level, at dialogue level, but also untrained and trained metrics. This part will be mainly covered by Chan Chen. This is part of his current research. And he will be explaining many different options, current options and state-of-the-art models on this. So we will finalize with the challenges and future directions for this field, for this topic, the things that we need to continue working on that, and we finally have some conclusions. Okay. So, but before starting this, I would like to check with the current participants, how many of you have experience working on dialogue systems or evaluation metrics? Can you raise your hands or open your mic for one moment and tell me if you have experience or previous experience on evaluation metrics or dialogue systems at this? So feel free, please, to open a little bit the microphones and tell us. Yuan or San, do you want to share? Or can you raise your hands there if you have experience on dialogue evaluation metrics? Okay, I guess the answer will be no. So we will try to go from the very basics so you can at least understand the most prominent efforts and ways. So we have tried to create this tutorial with different ideas in mind, having people with a lot of knowledge or having people with just basic background. So don't worry if you don't have really a lot of experience on this. The idea of the tutorial is to teach you all the way through the main metrics and main approaches. Okay, let's go for the introduction. So as you may know, or I can explain this, we have basically three different types of dialogue systems. One, what we call is task-oriented dialogue systems, where the idea is to complete a task. So usually if you want to buy a ticket, if you want to fly to somewhere, so you have in mind exactly what you need to request from the user in order to accomplish this task. So in this case, we call them task-oriented because all the chatbot, all the dialogue system is based on this transactional nature of collecting data from the user because we need those data in order to perform the specific task. Here, success is measured basically in terms of efficiency and brevity, because you want the user to get the information as soon as possible or to buy the ticket as soon as possible. And you want to be able to handle all the possible combinations of problems that the user could have. Let's say I want to book a table for 5 people, other ones to have a booking the same table but for 10 people, and so on. So you may have a lot of range of variabilities, but at the end, the questions or the things that you need to ask the user are exactly the same, because basically this covers the whole range of possibilities in this specific topic. So if you want also, there is another kind of dialogue system that is called chat-oriented. In this case, what we want is to have meaningful conversations. We want to chit-chat. We want to have some entertainment. Here, we can be switching from one domain to another domain. We can be talking about movies. We can later move into talking about music or sports. So you can be talking about any different things, but at the end, what you want is to have this engagement with the chatbot. So here, the success is measured in terms of more time for the user interacting with the system, and also probably ratings at the end of the interaction with the user. Here, usually chatbots needs to be empathetic, friendly, because you want the user to feel comfortable talking to the machine. And finally, we have interactive question answering systems, where basically you want to ask some few questions, then you get the information that you need, and then probably that's all that you need. And here, the success is measured in terms of response correctness. Maybe you just need one single turn to get the information that you need, and then you left, or maybe you need few turns to get all the information, or to ask different questions on the same topic. Okay, so when we measure or when we develop task-oriented dialogue systems, usually we combine rules and statistical components. So in this case, we have seen a transition from very old times when we have many different components to systems that are end-to-end. And here we wanted to give you some few links or papers that relates to the idea of task-oriented dialogue systems, but with neural networks. So I'm not going to enter into all the details of each of them, but in principle, most of the times what you are creating here for task-oriented systems is using rules and some components, unless you move into end-to-end approaches. But again, most probably you will be requiring the system to learn the rules, the steps for the system to get or collect the information. When we evaluate this kind of dialogue systems, as I mentioned before, the thing that we are measuring here is task success and dialogue efficiency. Probably the most well-known framework for evaluation was Paradise. This was proposed in 1997. It's a framework where basically you measure the system based on ratings. So at the end, the user rates the dialogue system at a dialogue level, but you try to learn using some linear regression model how the user how the user was satisfied with this system. So you have basically dialogue scores, you have task success, and you use this information to learn some regression model to be able to get information. Sorry, you have the survey on user satisfaction, and you try to learn the dialogue scores and task success based on this user satisfaction. So there are many features that you can be learning, but at the end, you want to have something that correlates with the survey that you do to the user at the end of the dialogue. So if the user say, I like this system, and the user says, I want to give 5 stars, then you check all these features that you have been collecting along the dialogue to check how you can convert this satisfaction score into different parameters inside. For instance, for dialogue codes, you may be looking into the time that the system was taking for completing the task. You may be looking into the word error rate, even because if the word error rate of the system or the ASR is really low, that means that the system is going to move faster, and then you will get the information quickly. So in those cases, we check the performance, and we learn this linear regression model. If we move then to the evaluation, usually we measure sentence level semantic accuracy. We also measure a slot error rate. We use F measures because we want to make sure that all the information that is required for providing the task or completing the task are correct, and you are extracting that information correctly from the dialogue or from the different terms. Then also you can have this joint goal accuracy metric that is very famous, very well known and used, because you want to check also the capability of the system to learn all these concepts and get at the end the final result correctly. There are other evaluations based on NLG approaches like correctness, like at the F1 score, or you can have also quality of the surface realization of the dialogue based on metrics like BLEU or Rouge. This will be explained more in detail in the following slides. So when we move into dialogue systems, open domain dialogue systems, then we have basically here systems that are based on retrieval methodologies like dual encoder LSTMs, conv-RT, BERT-based, polyencoder. What basically you are trying to do here is to check what is the question from the user, and then you look into your whole list of dialogue or previous dialogues, and you try to find the sentence that is similar to what the user is asking, and then collecting the specific answer for that sentence, for that question. So here what is evaluated, especially because it's a retrieval-based approach, what you are basically looking here is the MR, the mean reciprocal run, meaning that you retrieve information and the first option, the second option, the third option are correct. And if your correct option is lower, then you penalize the system because it's not selecting the first one as the best retrieve item. So metrics from the retrieval approaches are very common here. We are not going to enter too much in detail here because those are basically all approaches, and we want to move more into the more recent approach. Then also for dialogue systems, we have the end-to-end generative approaches, like we have the HRED or VHRED. Those are based on sequence-to-sequence models using RNNs. Then we move into transformers. Let's say we have the GPT, Dialog GPT, the Lambda, or these days, you know, we are moving into more complex systems based on encoding, decoding models like Plato, Mina, Blender, or this very famous chatbot these days, Dialog Chat, right? So then for the evaluation, we have ChatGPT, sorry, that's the name of the chatbot that these days are very famous in Twitter. Then we have these evaluation metrics we use to evaluate humans. Humans evaluate the dialogue. They use ratings or Likert ratings, turn or dialogue level. The Likert ratings is, let's say, from 1 to 5. If you give 5 stars, that means that the chatbot is really good. Or if you give 1 star, that means that the chatbot is not competitive enough. Then you can have also pairwise comparison. That means that you can check the performance of one chatbot against another. We will go into more details of this, but basically here the important concept is that humans are there to evaluate the system. Then we have also evaluation based on automatic metrics. Let's consider reference-based metrics like BLEU, Rouge, that we will be explaining later, or reference-free metrics like Perplexity, USR, and others one that we will also explain. And we have this ChatGPT. This ChatGPT, I guess you have been familiar with that because it's very on top of the news in Twitter. Everyone is talking about that one. If you haven't, then go, because you will be surprised by the capabilities of this system. So the question when we see the outputs of this kind of system is how good are these models and how can we measure if these answers are really good or not. And many people are questioning now if this kind of system has made the evaluation basically done or not, because they say those systems are so good that basically the evaluation will be always hard. But I don't think we can just say that. We definitely need to go for new evaluation metrics or more complex evaluation metrics, because at the end, you want to make sure that the system is faithful, that the dialogue is safe, or there is consistency in the long term. You may have a chatbot that is creating very, very good answers, like these ones on the left, but at the end, when you check sometimes they make mistakes, and those mistakes could be very dangerous to do. So we need to continue working on evaluation, because this is critical for the performance and the improvement of this kind of systems. Okay, then let's move into how do we measure progress. We have mentioned that we have different ways to evaluate. Basically, humans are the most reliable or the more important ways to evaluate dialogue systems, because humans provide accurate evaluation, because they are holistically understanding the dialogues. They also evaluate, or humans evaluate multi-dimensions, different perspectives of the same thing. And at the end, we can also agree from different annotators on this majority opinion. Of course, everyone has a different opinion of something, but at the end, there could be an agreement that a dialogue is good or not based on majority votes. When we also talk about human evaluation, we may have different ways to evaluate, or the human to be there to evaluate. For instance, you can have single model per turn. In this case, the chatbot is providing terms, and every turn, the human will check the quality of the answer of this chatbot for that particular turn. So you see in the gray color, there are the answers from the humans. So the humans are supposed to be always correct, but we want to check the performance of the chatbot. So we evaluate each of the turns by the chatbot and say if it's good or not. Or we can provide starts. Let's say, we can say at dialogue level, we say, okay, I check the whole dialogue, and at the end, I provide 5 stars, 4 stars to this chatbot. We can have also pairwise per turn evaluation. In this case, we have, let's say, 2 chatbots chatting, and then the human will say chatbot 1 or chatbot 2 is better in turn 1 or turn 2, and this information will go one turn by time. Or we can have pairwise per dialogue. In this case, the human will check the answers from chatbot 1 or chatbot 2 and decide that chatbot 2 is better than chatbot 1. And finally, we can have also chatbots chatting itself. So you can see here, chatbot is providing answer to its own response. Then after that response, the chatbot is asked to provide another response. And then finally, a human will say, okay, I prefer chatbot 1 or prefer chatbot 2. There could be also different evaluation criteria. Let's say turn level. We can see here grammaticality, relevance, informativeness. We can check if the chatbot is emotional or not, if it's engaging or not. So we have different dimensions at turn level. And then we can have also different evaluation criteria on dialogue level. So the dialogue level is more complex because it needs to check the whole dialogue, not only one single turn, but again, you can check for coherence, for consistency, diversity, informativeness, and all this information or all these dimensions are important to evaluate the chatbot. However, human annotations are very, very difficult, right? Because we need consistency, and sometimes when you ask experts, they don't provide the same answers as non-experts, or if you ask crowd workers. It also depends on the age, the mood, the math, the culture, the topic knowledge, the experience that this evaluator has from the past, or the expectations of the evaluator on the particular chatbot. So all this creates variability in the human annotations, and that makes it difficult sometimes to get accurate responses from different people. Besides, it's costly, time-consuming, especially if you increase the number of dimensions that the user needs to evaluate. This will create even more effort for them to spend. Then it's highly conditioned on the evaluation setup. So if you clearly not describe the task for the evaluator, he will be evaluating something that is different to what you expect. So it's very critical to have a clear description of the task. Also selecting the annotators. If you don't check the quality of those annotators, at the end you have a lot of scores, but those scores are not useful. So that's why we need automatic evaluation metrics. But remember, the goal of the evaluation, of this automatic evaluation, is not to replace the humans. We want to supplement it, because this way we create consistent, reproducible, efficient, and cheap process. What are the advantages or the attributes that we want to check for these automatic metrics? We want to check a strong correlation with human judgment. We want also the system or these metrics to be interpretable, multidimensional. They need to be also generalizable across different domains. We need also to be able to have robustness against adversarial attacks. What happens if you change one sentence with another and the system is not able to detect that you change completely the meaning of the dialogue because you move one sentence or you completely change the meaning of that sentence. And at the end, we also want this compatible with human evaluation, so human can be also in the loop at some point. And we have different categorization of metrics. And I want you really to pay attention to this slide, because this will mark the rest of the slides that we will be presenting. The first thing is that we may have what we call reference-based but context-free metrics. What is reference-based context-free metrics? That means that when we introduce to the model, we introduce references, goal reference, the reference that the system should be providing. It could be a single reference, or it could be multiple options for the same, but at the end, you have references. And then you have your hypothesis, and then you need to check how good is the system on this hypothesis or this answer in comparison with the possible good answers that the chatbot should provide. But when we move into context-based metrics, we can have also with or without references. Imagine that we have references. In that case, we have context, reference, and hypothesis. What is context? Context in this case means previous terms, previous dialogues from the same system. So in this case, the system receives as input not only the references, the reference could be optional, but it receives not only the reference, but also the context. And what you need to check is how the hypothesis is related to that context and how the hypothesis is related to the reference. So if you have context, then you can use it. If you don't have, then you may have hypothesis and also a reference like in the previous case, right? And again, we can have untrained or trained metrics. Okay, we are here now. I would like to ask if you have any question that you want to ask at this time. You can open your microphones and ask the question. Otherwise, we will be moving to the next part. Is there any question? No questions? Okay, if this is easy, then let's go to the next part. So here we are going to start with the reference-based metrics. Okay, so for the first part is untrained metrics. Remember, untrained metrics means that we don't need to train a model. We just base basically on surface level information. The first kind of metrics that we can find in the literature are character-based metrics. These metrics work at character or phoneme level. In this case, we are considering only lexical consistency. We are not really checking fluency, syntactic, or semantic integrity, because we are going character by character. So we can have examples of this, like a deep distance, Jacquard, Hamming, character, extended distance. So what are the purpose of those metrics? Basically, robustness. If you make mistakes in the transcription, or you make some mistakes on the user answers, so the system is robust against them because it's checking at character level. But really, in dialogue systems, we don't use these kind of metrics. So we are showing them, but we will skip them because they are not really frequent in dialogue systems. Then we have the n-gram-based metrics. These are based on word level or sequence of words, like n-grams. And the most common examples are Bleu, Rouge, Meteor, and Cider. Those are the typical metrics that you will find in the literature. And even up to date, and we will see some problems with these metrics, there is no any paper basically that they don't provide this kind of metrics. And when we read also in machine translation papers, we also find this kind of metrics. And these metrics comes from the machine translation field, and they come to dialogue systems, but as we will see, they are not really suitable for dialogue systems. But everyone uses them, everyone refers to them because it's easier to calculate. So it's very, very highly used because of simplicity and also because of tradition. Then we have also embedding-based metrics. In this case, we can see people using static or contextual vector embeddings. We probably know about Word2Vec, GloVe as static embeddings, or more contextual ones like using BERT or Elmo. In this case, the embeddings are trained on large corpora, and also they capture distributional similarity between words. That was one of the advantages of using vector embeddings, because they are not just capturing the syntactic properties of the sentence or the words, but they are also capturing semantic information. In this case, we can see greedy matching, embedding average metric. We can see also vector schema, BERT score. We will provide some examples of this, but again, these are not the main topic of the tutorial because they have been for a long time, many people use them, but we are trying to switch to more high-level metrics. Okay, probably you are familiar with BLEU, but if you don't, we will provide some quick explanation of what is BLEU. BLEU is the most popular metric proposed for machine translation, as I said before. It's intended to evaluate adequacy, fidelity, and fluency. So in this case, BLEU is an approximation makes an approximation for precision by using what they call modified n-gram precision. So in this case, what they check is how many n-grams or the fraction of n-grams that are in the candidate text, which are also present in any of the reference texts. So in this case, we are talking about reference-based metrics. So you need to have the references, you need to have the candidates, but then you start checking how many n-grams they share between each other. So the more number of n-grams or the higher order of n-grams, then we say that the system is better. Here, we also need to avoid having repetitive words or having arbitrary long text. Why? Because if, let's say, I can put all words in a vocabulary, and then because all of them are there and I'm not penalizing the length of the sentence, then at some point you will find those n-grams in the reference, also in the hypothesis. So basically you need to take care that you are not only checking unigrams, but you need to check also sequences or longer sequences like n-grams up to some order. And here we combine different orders of n-grams. So in this case, one of the problems with BLEU is that recall is approximated. There is no this way to measure in BLEU the recall. We are just measuring precision. However, in order to consider recall, what they say is, okay, let's consider that the sentences with same length or longer, they will have more options to be correct. So somehow we try to keep, we try to keep sentences that are longer without penalty, but sentences that are very short, we penalize them. So this is what is called brevity penalty, meaning that we try to keep the system generating longer sentences. But if you generate longer sentences, then you may make a lot of more errors in precision. So at the end, recall is somehow there because you are penalizing making errors in precision because of longer sentences. But if you make very short sentences, then you are penalized because you are not capturing all the possible words also in the reference. Let's consider this example, and probably this will make it easier for you to understand what we are trying to do here. So let's consider you have the reference. The way to make people trustworthy is to trust them, right? And we have this hypothesis. Then we have to make people trustworthy. You need to trust them. We check that it's not exactly the same. So, the meaning Probably it could be similar, but they are not the same. And in BLEU, we are not considering semantic correctness. We are considering syntactic correctness, or syntactically the same sentence. So we will check, let's say, using unigrams, we will check how many unigrams, how many words appears in the references versus in the hypothesis. So in this case, we check that we have 1, 2, 3, 4, 5, 6, 7 of these unigrams in the hypothesis are also in the reference. So for unigram, we will say the probability is 7/9. And why 9? Because the length of the sentence in the hypothesis is 9. Then you move to bigrams. In this case, you make also count how many bigrams are in the reference that are in the hypothesis. So we can see here, we have 5 bigrams that are also in the hypothesis. So now the probability is 5/8. And you will do the same thing for trigrams and fourgrams. So at the end, you have these results here, 3, 7 or 1, 6. Okay, so you can see that for fourgrams, the number of relationships or the number of matchings is very low, 1, 6, while here the probability is very high. So at the end, you don't consider only unigrams or bigrams. You need to integrate all of them and also consider the brevity penalty. So here we consider what is the size of the reference, the size of the hypothesis, then you calculate the penalty. And finally, you get the BLEU for M4, like 0.34. What is this? Is this evaluation here? You are introducing the brevity penalty and also the summation of the different probabilities. So at the end, this 0.3 means that the system is kind of okay, but the higher, the better. So what are the problems? Require multiple references for better handling syntactic and semantic differences. We are just considering precision, so we go until order 4. Usually, we could go to order 5 or 6, but or 7 or whatever we want. But in general, the longer the higher the order, the more difficult to get good results. So at the end, you don't want to penalize too much the systems. Recall is difficult to calculate. The average length is also modifying the result, and you don't know exactly if that length is good or not because you are not really considering the semantics of the system, of the sentence. Then they invented, or they moved into Rouge. Rouge is basically the opposite to BLEU. They are focusing on recall rather than in precision. So this Rouge is mainly used for summary evaluation, not for dialogue systems. But again, it's very common to find this metric in dialogue systems. So it is intended to measure coherence, conciseness, grammaticality, readability, and also content. We have different flavors of Rouge, but we will focus on Rouge N and Rouge L because those are the most common ones. So for Rouge N, basically you count the number of n-grams across all the reference, and we found how many of them are present in the candidate. This is very similar to what is done in BLEU. It's very common. And then we have also the possibility of considering sequences. In this case, what we call longest common sequence, LCS. And we have other flavors like weighted LCS or skip bigram concurrences. But again, the most common one is longest common sequence. That means you try to find those sentences or those n-grams or sequence of n-grams that are longer in the hypothesis that also occur in the reference. I think we can check again an example, and this will make it easier to understand. So we have again the sentence: to make people trustworthy is this part of the sentence is also in the reference. To make people trustworthy, and then you have to trust them. To trust them is this last part, right? So you can have RLCS that is 7/10, and you have also precision LCS is 7/9, and then you combine all of them. And you are combining this because you are taking into account how many of them occurs in the reference, how many occurs in the hypothesis, and finally, give weight to the recall and precision, and you get something like this, 0.73. So here, the higher, the better, because that means that the system is basically having sequences of sentences that are exactly the same in the references and in the hypothesis. And then we move into embedding metrics. We mentioned that there is greedy matching or average embedding. So what do we do here? Basically, we have word embeddings for each word in the reference or each word in the hypothesis. And then we do greedy matching. That means that you will go word by word in the reference and word by word in the hypothesis, and you will check which ones are closer to each other. And then you select the one with the max value for the cosine similarity. So if this word, I don't care about the order, but if this word is close to that word here in the hypothesis, then in the cosine similarity is higher, I will take that value. Then I move into the next word in the hypothesis. Then I will check all the words in the reference. And again, I go to the end of the sentence. And when I finish with the hypothesis, I will move into the reference. And I need to do the same thing. Why? Because there is the direction dependent. So you need to consider both sides. So that's why here in the formula you have you divide it by 2, because you need to check from reference to hypothesis and from hypothesis to reference. Or you can have something very cheap, very fast to do, that is average embedding. In this case, you compute a sentence embedding, a sentence level embedding. Then by averaging the word embeddings or creating a sentence level embedding, and at the end you check the cosine similarity between the hypothesis and the reference. And that similarity is basically your distance between hypothesis and reference. What are the advantages here? That is a cheap metric, but at the same time, it's a metric that is considering not only syntactic similarity, but also semantic similarity, because these sentence level embeddings or word level embeddings, they capture not only semantics, but also syntactic information. Or we can have BERT score. This is probably one of the most famous at this time embedding metrics. Is based on calculating the cosine similarity for each hypothesis token J, which is token I in the reference sentence, but in this case using contextualized embeddings created by BERT. You know, BERT is transformer-based, is having contextual information better than only static vector embeddings. So at the end of the day, you do a similar approach as the greedy matching, but in this case using vector embeddings based from BERT, and that will provide similar results. But because of the contextualization, probably your results are better than if you rely on the greedy matching or average embedding. And finally, we have the adequacy and fluency metric. This was initially proposed by Bunch and by myself in 2014 for machine translation, but later we modified this for open domain dialog system. And finally, Chan Tian also, he worked on this metric. He improved it through the integration of transformers, replacing the previous metric by using contextual embeddings using BERT as well. So what we do here, what is the main core of this AM-FM metric? We are evaluating basically 2 dimensions. One is adequacy, that means coherence with respect to the context of the reference, and fluency. So basically we are measuring syntactic and semantic similarity between the hypothesis and the response. So the advantage of this metric is that it's very simplistic. We are just evaluating 2 dimensions, adequacy and fluency, so it's very easy for people to understand. And at the same time, it could be context dependent or no context dependent metric. We can have references or we can have only context, so it's very flexible in this sense. And we also have the possibility of changing length of the sentences. So at the end, I don't care too much about which sentence is longer, which sentence is shorter, because we use relative scores. And actually, this metric also has been adapted to handle multilingual data by changing the encoder into a multilingual encoder. And we have been using this metric for machine translation metrics also in WIT. It's a challenge for machine translation that is very famous because it's on Asian languages. And every year that is run, we provide AM/FM adapting to the new languages, and it's very easy to adapt to new languages. So here we can see the formula for AM. Basically, what we are doing is cosine similarity between references and the hypothesis. And for FM, what we are checking is perplexity. But because we want to have a relative score, so we select which one is providing the minimum perplexity, and we divide it by the maximum perplexity between the perplexity of the hypothesis and reference, or also divided here for the one with the higher perplexity. So at the end of the day, what we have is, if the sentences are similar, they should have similar perplexity. If the sentences are correct grammarly talking about, then they should have similar perplexity as well. And if the sentences are close in the semantic space, then the AM should be able to provide this result easily. Then we move into train metrics. We can have here context-free or context-based metrics that contain learnable components trained for automatic evaluation. In this case, what basically people are doing is to combine different heuristics features that we extract from the dialogue, and then we train a system or a model to be able to predict the goodness of this metric. So what we use here, for instance, we can be extracting as features the n-gram precision, we can be extracting the recall, the BLEU, meteor scores, but at the end, we want to use, let's say, an SVM model, like in the case of Blend, or we may be using some linear regression model to put all this information, all these features, and then try to create or to predict what will be the output from humans. So we have a regression model, we train the model, we train the weights for each component, but at the end it's very simplistic because we are considering here the necessity of having humans to provide the scores. We have also, depending on the number of features, we may have a more difficult metric, but at the end, it's also for you humans very easy to understand, because you will see based on the weights given to each feature, which one contributes the most to the selection of the final rating. So it's very easy to understand. There are different flavors. Here we are just presenting some few of them. And then we have BLEU RT. BLEU RT basically is moving into end-to-end. This was one of the first systems moving into transformers models. And they also take advantage of these transformers for moving into contextualized word embeddings. So you need also to train this based on evaluation with humans. But the advantage of BLEU, or the main point with BLEU RT, is that they pre-train this BERT based on millions of synthetic examples, because they wanted to have a system that is generalized, that is able to generalize and also able to handle multiple subtasks. So basically what they did is, okay, I have human evaluations, so I will be fine-tuning my model on those human evaluations, but before doing that, I will be training the system with different tasks or automatic tasks to predict when this sentence is synthetic or is real, and the system learned to be robust for different variations of the sentences. And okay, this is the last part of this section. If you have any question, this is the time, or otherwise we will be moving into the next part. Is there any questions from the audience?